what we're going to do now is run the random forest. So let's do a new text header, random forest. This is a different header than the other one because it's subheader. And let's go ahead and do it. So I've got the scores. I'm going to redefine as cross-file score. Everything's been imported already above, and I'll reinitialize the random forest classifier as the estimator, comma x, comma y. I cannot see it. And I'll just leave the defaults up, and then we will compute the mean, the average score. Okay, so let's give this a whirl. And you can see that it is in fact building. Right here is indicated by the green arrow. And note that it's not just immediately outputting a score. Even though this is a sparse matrix, X is a sparse matrix, okay? Because that's how we defined it up here, right? X is this final matrix that's sparse. And then, but it's still significant because if we go back up to the size, I mean, look, it's 362,000 entries. And it's building 100 decision trees on that, right? And it's also building five different times. Okay, so this is taking some time. You can see it's showing down here the execution is at 48 seconds right now. What we'll look at later in this class is how to put in our own timers instead of relying on Colab, and we'll also look at different ways to improve the times. Okay, while we're waiting for this, what we can also do is check to see how do we do it with previous scores on this data set. Note that like when you're creating the sparse matrix, you're not changing the data, you're just selectively ignoring the zeros. Depending on how you look at it, I guess. Well, let's see. Is this the right one? This does look like it. So this is the previous notebook we created in this class, decision tree classifier. I'm looking for some scores here. Remember, this was the overfitting because we introduced decision trees. So we got like 82% when we split it out into a training and test set. And these are examples of overfitting, how when you increase it, these are not legitimate scores. But then when we did on the grid searches, yeah, so we got about 85%. And so this is like slightly tuned. We're only tuning it on, the max depth. Okay. And so let's check to see now how we're doing in the, that's not it, the one hot encoder. And we got about the better scores that we got with the decision tree, like 85.6%. Okay, so that's interesting. If you want to compare it straight to a decision tree, you can. I don't know that we need to do that here. What we're going to look at, so that takes some time to run, so I don't want to run like a bunch of these with this data set. But what we will look at, by the way, if you want to do this for fun, you can see how long it takes with the P to get dummies for comparisons. What we'll look at in upcoming sessions is now how to tune the random forest. And we'll look at also going forward, we'll look at some different timing techniques. We'll go back and forth between kind of neater, smaller data sets just for the purpose of getting to know the models and kind of bigger data sets where timing does become a factor, as you can see it clearly does here on this particular data set. I guess before we conclude, not that we did have the two different data sets. If I go back to this first one, I called everything the same thing. I just want to leave you with maybe just a little bit more about random forest with something that's a little faster. I guess I could do it up here. Let's do it up here. So if I come back to the top, I run that. See, the reason why I'm doing this is because I redefined X and Y. So now it's the previous X and Y. And then we got this score, okay? And it did it pretty quickly and got a slightly better score that time. There's obviously randomness involved. Well, let me just show you just a quick couple things. So if you want to change this, you can change the initializer. meaning like in estimators is the number of trees. And so for instance, you can check, I believe the default is 100, so you can see, well, what if I do like 200? Will I get a better score? Let's run it and find out. And see, it actually takes a little time. It's twice as much. No, we didn't get a better score. What if I keep going? It's kind of interesting, right? You might think, well, if I do more trees, I'll clearly get a better score each time. It's not necessarily true. See, that one's better. But generally, I feel like it sort of is. I can tell you from experience. It's just that it peters out after a while, right? I mean, you can see now it's starting to take a little longer, right? And this is from a small data set because, that's 800 and you can see it's not doing it. Now you can, by the way, set up these, oh gosh, what is it? Random states. So we haven't done it. And this should, it doesn't all, sometimes it doesn't always work in the way I want it to, but it should like kind of do, if you pick like a number like 2, you can pick anything for random state. Then I'm thinking what happens is you get the same result, but somehow it doesn't always work like you may think, right? It's like each time you create a random forest, there's randomness involved. And so when you are in fact, was that the same 818251? When you are in fact, yeah, it is the same. So it's not that, well, this is the official one. It's just, this is this random state because you get different scores with different random states, right? But it allows us kind of for better basis of comparisons, you could say, the more consistent. And so if you put random state equals 2, you should get the same thing. But again, like there's variation. So does this mean 200 is the best? Not necessarily, right? You can see that they're kind of close. I can go down to 50 decision trees now. I mean, hey, you could go 10 decision trees. You could go 1,000, right? You could really pick any number. And we'll look at some cool techniques where you can see how it changes over time, okay? But this was kind of a long session overall. It looks like that the middle, like around 400 is what I'm getting to be the best. You can kind of play around with these. And again, we'll look at different techniques beyond, say, grid searches. Because, see, for a grid search, like, it's going to be different depending on how many estimators you use. And it can be nice to actually do a grid search on the other parameters, which include other decision trees. Like, for instance, you know how there's max depth for a decision tree? Well, you can put in max depth and you can say, oh yeah, I want to pick one of those middling numbers, right? Because it's the decision tree. It's 100 decision trees. And so it's going to have the same hyperparameters as the decision trees, right? And so now each decision tree, you can see it does a little better. It only has 6, a length of 6. Okay. And so this is just some initial playing around that we can do to kind of, get a sense of how it's going to work. Okay. So this is just trying changing in estimators and max depth to improve scores. And really, even though we will look at random forest a little more, I do want to mention that you do basically have all the key techniques because previously we've looked at decision trees. All those hyperparameters are good here, but there's simply more here, which are how many trees do we have, and along with a couple others that we'll check out.